All right, so I took this thing and I just showed you this. I could make it a little closer if you wanted to see, a little closer up view, and you can go out like this. You can see a little wider view. Let's go so I can see all those angles. That's good enough. Now remember what I said? It starts here. Let's say you start right here at 0 degrees, okay? Because you could start anywhere. There's no real starting point, is there? I mean, you can start anywhere. Let's just say we're starting at 0 degrees, and we go up like this. That's only halfway around the circle, isn't it? So this isn't one full rotation of a circle. What's one full rotation of the circle? Here and stop me. Bang, right there. Good. 360 degrees. All right, so that's one rotation of the circle, and you can see where we get these. So now I made this little thing. Yep. And check this out. This is kind of cool. If you look up here to these numbers, they're a little bit small for you, but you could see them. If I go like this, see what happens as I go to 30 degrees. Look what happens on the y-axis. So if this thing goes across like this, you see what happens on this y-axis, and you can see your numbers as well, which is kind of cool. Tell you what, let's blow this up just a little bit more, so we can. Oops. No, I can't really make the numbers. I guess I could, but I'm not. What numbers? These numbers up here, they represent. This is the angle. It's the x and y. Right, so this is your x-axis, your angles, and this is your y-axis. That's your value of the function. All right, so that is like 29 degrees right there, and that's 0.48, which is just a little shy of 4. So what if I get exactly at 30? What should this number right here be? It should be a half, right, or 0.5. So let's see. There it is. See, I'm at 30 degrees, and so I'm looking at the A point right there. I'm at 30 degrees. That's the point B. Right, see the 30 degrees, 0, that's this point, and the C is that point right there. I just took the B and the C off of there just so you can see the A. And then, so what I'm doing is if I take this to 60 degrees, try to pop it right on there. Sometimes it's hard to catch it right on there. That one's not locking in. They were kind of snapping right to it last night. Maybe you have to blow it up a little bit more. Let's see. See if I can get it right at 60. Bang, right there. Yep. Look, 60. See, that's 60 degrees. It's 0.87. Remember we said it was 0.86 something. I guess it rounds to 0.87. And that's what the value is. Now, what is 0.87 though? That's calculator value. What's the exact value of that? Of the 0.87 one? Square root of 3 over 2. That's right. Because, look, the sine of 60 degrees, do you see what this is doing? This is giving us the sine of 60 degrees. Because this is a sine function. All right, that's what I did right here. It's a sine function. So the sine of 60 degrees is square root of 3 over 2. Now on this, it's just giving you decimal numbers, but it's 0.87. So if you drag this to 90 degrees, it snaps right on 90. Look what the y value is. It's a 1. So that's kind of a neat little thing to show you. Just drag it along. Now watch, if I wanted to, I could just have some crazy angle in between, right? We're just dealing with those special angles, but I could have some crazy angle in between, 107.59 degrees. And what's the value of that? What's the sine of 107.59? Who's got a calculator? Punch it in, see what you get. 107.59, take the sine of it, and 0.95, right? It's 0.95, right? So it's 0.95. Does that make sense? All right, so that's what this thing does right here, which is kind of cool. 120 degrees, that's one of our special ones. So let's try to snap it on 120. It's not really getting it, but it's close enough. I got 0.03. I can't get it right on 120, but again, it's 0.87, right? So 120 degrees and what? 60 degrees is at the same spot, isn't it? Do you see how they're across from each other like that? All right. And that works with the circle too. Look at the circle, all right, and look at 60 degrees and look at 120 degrees. Remember, the 60 degrees is kind of like that that reference angle for that 120, right? All this stuff we talked about yesterday, all right. At 180 degrees, snap on 180. There we go. I guess I got to be right on the line. At 180 degrees, what is it? It's 0, right? So those numbers are. I mean, that little thing is kind of neat because it shows you exactly, where you're going to be, all right? That's what's going on. Let's go like this. So what happens to the y as the x goes across? Look at that. Oops. What happens to that y? Look at right here. Watch this thing right here. What's it doing? It's just going up and down. It's going from where? From -1 to 1. Do you remember, I think in here, did we talk about range and domain and domain and range and stuff like that in here earlier in the year? I think we did. Yeah, we've done domain and range. So what's the domain and range? Well, the domain are all the possible x values. What are all the possible x values? All of them, all the real numbers, exactly. All right, what about the range of this thing? Now the range is the up and down, and that's what's cool about this little program, is you can see that up and down. Let's make it a little bit bigger. You can see that up and down. What is the range? If I could grab onto that. Come on. Click on there. What's going on? There we go. It is not liking me trying to get that point. Why am I not? Oh, no wonder, because that's not the point I want. I want this thing right here. Yeah. Let's try this again. I told you, this is the first time I've used this program, so. All right, see it? Watch. Look what it's doing. Forget all the other stuff. Forget all this stuff around in here. Okay, just look at the y-axis, that red dot on that y-axis. It just goes from -1 to what? To 1. So that's a good visualization of what the range is. Do you see it? So the range is just how far it goes up and down. So you look at it and you say, oh, it goes from -1 to +1, and that's the range of it. Make sense? All right. Now, I'm not going to take as much time on the cosine because you have an idea of how we graphed it. I'm not even going to sit there and graph the points of the cosine. I'm just going to show you. But you should be able to do this. You should be able to do this by hand, all right, and plot the points. 0 degrees, what's the cosine at 0 degrees? The cosine at 0 degrees? It's 1, because the ordered pair is 1, 0, right? So it's 1, 0, so the cosine is 1. Let's get rid of this. Let's kind of clear all that out of there. And get rid of that, and get rid of that. Okay, let's do the cosine this time. Now watch. Boom. This is what the cosine looks like. Let's blow it up a little bit. Alright, now look at this. I'll just point this stuff out to you because we should know now how to graph the thing, but let's just look at some of the key points. The cosine at 0 degrees. In fact, let's just do a little xy axis up here. And where's the pen? Okay, just do a little xy axis just to help us visualize it a little bit. That point right there, remember, it's 1, 0. What's the cosine at 0 degrees? It's 1, so check it out. It's right there at 1, isn't it? Okay, that works, doesn't it? What about 90 degrees? What's the ordered pair there? That's 0, 1. What's the cosine, guys? Whispering's not helping. Might as well just talk out loud. It's the same thing, okay? It bothers me just as much. All right, what's the cosine at 90 degrees? It's 0. So look, at 90 degrees, guess what? Look where that graph is. It's right at 0 on the y-axis. You see how that works? All right, at 180 degrees, the ordered pair is -1, 0. So what's the cosine at 180 degrees? Here's 180. What's the cosine? It's -1. Isn't that cool how that works it out? Really, so when you're plotting this, if you want to get an idea of what this is going to look like, you don't really have to do all those in-between ones, do you? You know it's going to be a nice smooth curve, and you know it's kind of oscillating, right? Kind of like this. All right, you know it's going to look like that. You just need some key points where it's going to go through, where it's going to start, and that kind of stuff. If you just do the quadrantal angles, but you got to realize it's not just going to be a straight jagged line from here to here. But you just kind of hump it over like this and come down, just kind of make it a smooth curve like that, like a wave. And that's what these things are. These are waves. All right, man, these have a lot of practical use, like your radio, like AM and FM, right? FM is frequency modulation, AM is amplitude modulation. It all has to do with curves like this. I mean, it's incredible how much times these are used. Let's go one full rotation. So if I go to 270, at 270, what's the point right here? That's 0, -1. Remember, we're doing the cosine. I should have written this up here. We're doing the cosine, aren't we? So the cosine is 0. So at 270, you put a 0 right there. Back to 360, what's the cosine at 360? It's 1. And then it just starts that whole routine all over again, doesn't it? Does that make sense? All right. Remember what I said earlier? I said, let's say we pick that as our starting position. Where does it begin the next full rotation? Does it begin down here? Is that one full rotation? No, that's only halfway through. But then we get up to here. So basically, I'll circle them. Basically, from here to here is one full rotation. Would you agree? All right, so from here to here. We give that a name, and we call that the period. All right, period basically means time. Well, in physics, I'm thinking physics, period is time. But this basically means, you go to class period. It starts, they're all the same amount of time. Then you go to the next class period, and it's the same amount of time. So watch. You start here, goes like this, and then it starts the whole routine all over again. We call that the period. What we're trying to do is find out what the period is. The period is how many degrees, all right? Oh, I better stop and then start again. You almost missed it. Oh, is it still running? Oh, I gotta go on. I always forget. I gotta go on that thing.